So listen carefully. The province may only ask you to calculate one of these. Okay? Make sure you follow along, page 52, guys. They might only ask you to find the sum of interior angles or the measure of each interior angle, central, exterior, and so forth. So if it asks you for the sum, figure out the number of sides. The question may say it, or that you might have to count it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. N is equal to 11 in this case. So the sum calls for this formula. So it's going to be n minus 2 times 180. If you know what you're doing, this would be an easy mark. So 1,620 degrees would be the sum of all the interior angles in this particular polygon. The more sides, the bigger this number gets. Okay? This is the sum of all interior angles. Some of you might have to write this down. If you add up all 11 interior angles, you get this amount. The interior angle calls for this formula. So that's 11 minus 2 times 180 over 11. And so basically, I don't know how fast you're writing this down, but basically the 9 times 180 is the same as before. It's a 1620. So you just take the 1620, divide it by 11. So I have this on my screen still on the calculator. I'm just going to divide it. And yes, you do get decimals sometimes. Don't forget your degree symbol if you want full marks. Okay? So each interior angle, right, measures 147.27 degrees. Exterior angle, the formula is quite straightforward. It's just 360 divided by 11. That's 32.73 degrees. The central angle you know what? How else could you have found the exterior angle? Minusing it from 180. Like if you have your interior angle, you know these two add up to 180. So you could go 180 minus 147.27. You still get the same answer. Okay. Wow. I know. And the last one, this would be a central angle. I should write that down. Each central angle, okay, this is the measure of each central and each exterior. I'm going to write this down. Each exterior. And what's the last one? The number of diagonals. You can draw it, you can sketch it, or you can solve it. I will say solve it. I'm going to do that over here. The formula is n times n minus 3 divided by 2. Just get your formulas right. It is right here. All the formulas, I get them from the formula sheet. I'm not making them up. Okay. So this would be 11 times 11 minus 3 divided by 2. Clean it up. That is 8. At this point, you can do the math, right? 11 times 8 is 88. Divided by 2 is 44. Yeah, I know. I hear you. 44 diagonals, right? So if you were to connect all the corners, you have 44 lines going on in there, which is too much work. I'm going to ask you if you're interested in trying a 30-sided polygon, see the key that I posted, okay? No, not right now. I want you to go to 52, bottom of 52, this diagram here. This one. Actually, assume this is an AC. I'm asking you right now, can you label on this diagram, can you label one interior, one central, and one exterior angle? Just one. Could you do that accurately? See if you can do that. That's 3 marks. Label one interior angle, like put an I where the interior angle should be, put an E where the exterior angle should be on this thing, and put a C where a central angle should be. Like ICE, basically. ICE. Those ones you should not waste time on, just move on, right? So you pick any corner on the inside. I'm going to pick this one right here. Just put an I there. So you're telling me which angle you're talking about. I. Exterior, pick any corner you want. Any 2 sides that meet and just extend them. And that is your exterior angle right there. That's 1. Okay. Central, go to the center and just make a slice like this. That angle right there is central. Okay, 3 marks. Take it or leave it. Let's keep going here. Okay, how many sides? Count them. You count them. Don't say it out loud. You count them. If you're off by 1, the whole thing goes down the drain. So you got to make sure you count them properly. Put a check mark. Should have gotten 15, hopefully. And if I asked you for A, what is A? What kind of angle? What do we call that one? Interior angle. So technically, if you want to solve for A, you should use this formula. Right? That's what we're going to use. This is an interior angle. So they won't always tell you that. They're just going to assume you know that. So angle A is 15 minus 2 times 180 over 15. That's 13 times 180. Let's see if this is a decimal or not. It's a whole number. 156 degrees, guys. So it's getting really close to 180. Like, if you, it could, if you keep on going, you would have almost a perfect circle, right? What's C here? What's this one? Exterior. So to find angle C, you're not thinking central angle now, okay? This is angle C where it's located. It's the exterior angle. You go 360 divided by N. And that is 24 degrees. Does it make sense that this one is 24? If you look at the interior angle, they should add up to 180. The interior and the exterior should add up to 180. What about angle B? What angle is it? I talked about it yesterday already. It's almost a central angle, but not quite. I had to ruin it, right? Why do you always do curveballs? Like this one. There are two central angles there. Let's call it X and X, right? So to find angle B, it's 2 times angle X. Does that make sense? You don't have to do it this way. You can do it your own way. But I'm going to find a central angle. Central is 360 divided by 15, which we already know is 24 degrees. And that is what I'm going to plug in here. So angle B is 2 times 24, which is 48 degrees. Okay? So angle B is 48 degrees. It's 2 central angles wide, okay, or the measure of the angle. Next, 53. I need you to know the names. You seem to be pretty good at names of polygons. I just need you to know the first 10 or so. And I'm just going to focus on the prefixes. So go to 53. I'm not going to bother filling this in. Like sometimes when I have time, I'll do it. But I need you to know the prefixes and the name. The number of sides and the name, I should say. If it's a 3-sided, it's a triangle. If it's a 4-sided, it's quadrilateral. 5, penta, hexa. This one here, listen. 7, I don't know if a lot of you are familiar with 7. It's hepta. 8 is octa, nona, deca. They skipped 11 for some reason. Dodeca. Okay, dodeca is 12. Deca is 10. Dodeca is 12. If you go past it, they start just calling it by what it is. A 20-sided polygon or a 13-sided polygon. There is no name for it, okay? So sometimes they have asked you, like, hey, how many, like, what would this shape be called? You're essentially classifying it, okay? All right. Almost ready for the AC. Let's go to 54. Working backwards. Last semester they had a backwards question in there. Actually, it was exactly the same as the first one we were going to do. When you're given the psyched values, right? So either the sum, the interior, or something, you have to determine the number of sides. So here's an example. The sum of interior angles is 3,060 degrees. Determine the number of sides. Listen to this part. You cannot guess. Guessing is okay for you to know whether or not you're doing this right, but you have to show the work. So you focus on what is it saying that this number represents. It's the sum. What is the formula for sum? Right? N minus 2 times 180. Which one of all of these things do we know right now? We actually know S. We know this number. So you substitute that in. So you go 360, you put that in there. And here's where you can do a number of things, but I'm going to tell you which one is better for you. Okay? Watch this. I'm going to divide both sides by 180. Instead of multiplying it out, I'm going to divide both sides by 180 degrees. Cancel them out. do the math on the left side. That's normally how backwards works, okay? That's 17. So you get 17 here. And on this side, you can lose the brackets and just be left with n minus 2. What do we do now? Plus 2, right? Plus 2. We add 2 to both sides. And then it's n is equal to 19. So it's a 19-sided polygon. Can you try B real quick? B is also doable. See if you can do that one. Give it a try. Ready? I know it's Friday, but let's finish this. Exterior angle. What formula are you thinking of? E is equal to 360 over n. You're gonna love this one. If this one shows up on the exam, you're gonna love this one. E is 1125. And on the other side, you have 360 over n. What does this remind you of? You've done so much of this. Put the 1 there, just for kicks. You cross, multiply, and divide. That's it. So n is 360 times 1 divided by 11.25. I know you can omit the times 1. I know that. But it helps you realize what's happening. So if you do that, 360 divided by 11.25, you get 32 sides. Here's this one. The next one could be really hard, or it could be the same as what we just done. Okay? A regular polygon has interior angles of 171. Which angle? Interior. Calculate the number of sides algebraically. What's the formula for interior angle? This, right? Isn't that ugly to solve? I would say so. What did I tell you about interior and exterior angles all this time? What do they add up to? 180, yeah, somebody said that. So couldn't I say that if the interior is 171, couldn't I say exterior is going to be 180 minus 171? So the exterior angle is what, 9 degrees? So basically when they said the interior angle is this, they're also saying the exterior angle is 9. So now you're using this formula instead, where the 9 is, right, you're going to substitute that in there. Like so. You put the 1 underneath, times, divide. 40. Oops. 40 sides, yeah. So can you give yourselves a little note on your study sheet to make sure you know that the exterior angle is 180 minus interior? Maybe you need to actually write that out. I'm just using letters, but maybe you say that the exterior is 180 minus the interior. Okay, and so you have a little note in your okay.